Hi guys, welcome back to the channel LeetCode and Sleep. And today's LeetCode problem is a bag of tokens, and this is an easy problem here. And the topics for this are it's a grading problem, and we'll be solving this problem using 2 pointers. Okay, and so let us quickly dive into the problem statement here, and let us see what's the problem statement is. So here they are given you start with an initial power of power. Okay, power is given with you and initial score of 0. So we will be starting with an initial power of power and a score of 0. Okay, and a bag of tokens given to you. Okay, given as an integer array tokens, where each tokens I donates the value of token I. So the tokens I array basically represents every ith index, every index has some tokens, and those tokens we need to donate, it seems. Okay, and so our goal is to what's our goal is, our goal is to maximize the total score by strategically playing these tokens. Okay, so by strategically playing, what this line means is, so there are we have to play with the tokens so that we get the maximum score here. Okay, so how to play the tokens we'll be seeing in the next steps. Okay, and one move, so you are given with one move, so in one move you can play an unplayed token. Okay, so there are array of tokens, right? So we can play with a token only once, right? So this is the statement here, we can play it play with the token, like play with the ith token only once. Okay, and so if the token is not if token is an unplayed token, then we can take the token and we can play with the token. Okay, so in one of the two ways, so we can play with the token unplayed, we can play with the token which is unplayed in two ways. Okay, so there are the two ways are here, face up and face down. Okay, so what is face up? Okay, if your current power is at least tokens of 5, so at least tokens of 5 means, so here there are given with power, right? So if our power, like if I have some power which is greater than my token of 5, so we can play that face up play here, face up role we can play here. Okay, okay, you may play token I losing token I of power. So when we want to play with the token I, where the power is at least token of I, so we can decrease our power by token of I, and we can increase our score by 1. Okay, this is the statement here. In one way we can increase our score by 1 and we can decrease our power by token of I. Okay, and what is face down here? Face down move is, so if your current score is at least 1. Okay, so if the score of your current the current score of your the current score of you should be at least 1. Okay, the score of your the score should be at least 1. Okay, when the score is at least 1, then only you can play this move here. Okay, so what is this move is, you may play token gaining tokens of 5 power. Okay, so here we can gain some power. Okay, what the power is, ith the token, right? Ith the token power we can gain by decreasing, by losing one score here. Okay, uh, we can have two moves here. One move is we can lose token I of power and gain one score, and the other move is we can gain one score and lose, and we can gain token of I power and lose one score here. So these two moves we need to apply on a token of I. Okay, so that we can get a maximum score here. Okay, so return the maximum possible score you can achieve after playing any number of tokens here. Okay, so if you see the token, if you see the problem statement here, here there are we are given with two choices, right? So as we know, if we have choices, we can think of a DP approach right here. So actually here DP approach fails here. Okay, so we need to think in a broader way, like in a greedy way here. So the greedy approach is like, so basically let's visualize the problem, example statement here. Okay, so here they are given with tokens like 100 and power 50. So now I am at the 0th index, right? So I am at the 0 index, I will be checking like whether I can perform my face up operation or not. Okay, so face up operation requires what? So it requires our current power should at least be tokens of I, right? So if we see here, 50 is our power, and tokens of 0 is 100 here. So power is lesser than tokens, right? So we cannot perform face up here, right? So we cannot perform face up. So let us check whether we can perform face down or not. Okay, so let us check that whether we can apply face down here or not. So for face down, what should be our score? It should be at least 1, right? So initially our score is 0, right? So we cannot even perform face down here. So for this, the overall score will be 0 only, right? This is the example statement here. Okay, now let us visualize the second example here. Okay, so now, let us visualize this example here. Like there are given 200 and 100 tokens here given, and power is 150, and our initial score will be 0 only, right? So first, whether we can apply our like, so what we do is, what did he do is, he taken token 1 here. Okay, token of 1 here. So he taken token of 1 and applied face up here. Okay, so face up requires the power should be at least tokens of I, right? So tokens of I is 100 here, and the power is 150, so it is greater. We can apply face up here, right? So we have applied face up here and decreased our power to power by 100. And if we decrease our power by 100, what will be the power here? Our power will be 50, right? And when we apply face up, what we do, we will be increasing our score, right? So we have increased our score, so score will be 1 here, and we will be applying on the token 0 here now. So here at token 0, so can we apply face up here? So our power will be 50 here, right? So we have decreased 100 from our power, right? So our 50 will be a power. So 50 is lesser than our 200, right? So we cannot apply face up here. Like we cannot apply face up here, right? So we'll try to apply face down here. Okay, so face down requires score at least 1, right? So score is 1, so we can apply face down here. So but see, observe here, if we apply face down here, we'll be decreasing our score here by 0. So what we need to do, we need to maximize our power, right? So maximize our score, right? So here if we apply face down on this token, we'll be decreasing our score, right? So this is what the greedy approach we need to think of here, right? So when we will be not doing anything here, and we will be just skipping this token here. Okay, so there is no need to play token 0, since you cannot play it face up to add to your score, right? We cannot apply face up, right? So face up, when we apply face up only, we can increase our score, right? So when we apply face down, we will be decreasing our score. So this is not a right way, right? So this is not a right way, so we'll be not playing that token here. Okay, so this is how we'll be solving this problem. And okay, and let us visualize the example 3, and let us know some things here. Okay, so now as you can see here, the tokens are sorted in an order, right? It's sorted in ascending order, right? So now our score will be initially 0, and score will be initially 0, right? Score will be initially 0, right? So and I will be standing at 100 here. Okay, so now can our power will be 200 here, right? Like let us write power also here, power equal to 200. Okay, so now can I apply face up on token 0? Yes, I can apply face up, right? So because our power is greater than the token of I, right? So we can apply face up here. So I will be applying face up, and I will be decreasing my power to 100 by 100, and I will increase my score to 1 here. So now I'll move to second index, right? So now I'll check whether I can apply face up here or not. So I cannot apply face up, right? So here when you see here, 200 is the token I, and token I is, so to apply face up, what is the required condition? Our power should be at least token of I, right? So it is not at least token of i, right? It is lesser than token of i. So we cannot apply face up here, like a face up on this token here. So I'll be applying face down on another token. So to apply face down on another token, I'll be applying face down on the greater token here. So this is what the trick here. So this is what the trick here. So I'll be applying face down on greater token here. Okay, so what is the greater token uh, in our tokens? So when we sort it in an ascending order, the last index element will be the greater token, right? So I'll be applying so let us check whether this is played or not. This is not unplayed, right? This is right now, this is unplayed, right? So we can apply our play right here. So I'll be applying face down on this token here, like 400. So and what is the face down here? We can increase our power, and 100 plus 400, what it will be 500, and we can decrease, and we will be decreasing our score, right? So I have played 100 and 400. I have applied 100 on face up on 100 and face down on 400. Now I can apply face up on 200, right? So now I will be applying face up on 200. So what is face up here? We will be decreasing by our power by 200. It will become 300, and I will be increasing my score here. So now I'll move to another index and check whether I can apply face up or not. So now can I apply face up here? Can I apply face up here? Yes, I can apply, right? So because our power is at least, it is at least a token of i, right? So it is equal to token of i. So I can apply face up here, and this power will become 0, and it will become 2 here. So this is how we greedily apply this tokenization, and we will be solving this problem here. So from this example, what we got is we need to sort the array, right? So we need to sort the tokens array so that we can apply face down on the greater index, right? So for that for this we can apply face down on greater index, right? So in this way we'll be doing this problem here. And so let us quickly see the code of this problem, and let us observe here. So what I did is I'll be taking 2 pointers here, and one will be starting from for face up I'll be starting it from 0th index, and for face down I'll be starting it from last index, because for every face down I'll be maximizing my power with the last index only, right? Because the array is sorted, the maximum tokens will be at the last index only, right? So I'll be starting with my j from last index here. Okay, so initially our score will be 0, right? I'll be initializing my score with 0, right? And for sure we need to sort the tokens, right? So I'll be sorting this token. So now I'll be applying a while loop here. The while loop will run for I is lesser than or equal to j here. Okay, so now this is the condition. Can I apply face up on index I tokens, right? We'll be checking here, can I apply face up on index I tokens? So I'll check. So what is the condition? Our power should be greater than or equal to tokens of array, right? So the power is at least tokens of I means it should be greater than or equal to tokens of I, right? So I'll be checking whether my power is greater than or equal to tokens of I. So if it is greater, then I can apply face up here, right? So I'll be applying face up here. Okay, so the face up is I'll be decreasing my power, and I will be increasing my score with by 1, right? So I'll be decreasing my power by tokens of I, and I'll be increasing my score with 1 here, and I'll be moving my I to next index. Okay, so now I'll be moving my I index to next index, right? Or else, so if it is lesser than or lesser than tokens of I, that means we cannot apply face up, right? So we'll check whether I can apply face down or not. Okay, so for face down, what is the condition? Our score should be at least 1, right? So for, the score should be at least 10, that is greater than 0, right? If the score is greater than 0, and this is the condition we need to check here. Okay, j minus I greater than 1. So the condition is j minus I greater than 1, because see when we are here, like I is here and j is here, okay, and I is at 1 and j is at 2 here. Okay, so okay, so I is at 1 here and j is at 2 here. Okay, so uh, uh, for somehow we got uh, for applying a phase up here, we the condition is false here, so our power is lesser than like let us say 100. Okay, at 200 we have the for applying a phase up on 200, we have power lesser than 200, so we need to apply phase down, right? So when we apply phase down here, so we need to apply phase down and decrease our score, right? So I'll be applying phase down here, so I'll be increasing my power with that 400 and I'll be decreasing my score with minus minus. So after applying phase down, for applying phase up, like we need to maximize our score again, right? So for maximizing our score, there are no tokens left here. So if you observe here, like when we want to so our I will move to this index, this at this index we have applied phase down, right? We have applied phase down here, so we cannot play it again, right? So there is no way to increase our score again, right? So uh, when we need to apply phase down, right? Phase down means when our j minus I is greater than 1, that means there are more indexes for applying phase up, then only we can apply phase down here. Okay, this is the greedy thing we need to visualize here. Okay, so this is the main thing here. Okay, this is the main thing we need to visualize here. Okay, whenever there are more tokens, like whenever there are more tokens for applying phase up, then only we can apply phase down here. That is the condition here. That is what. So how we can check whether there are more tokens or not? That means when the like j minus I is greater than 1, that if j minus I is greater than 1 means that there are that means there are more tokens to apply phase up, right? So there is more chance to apply phase up, whether they work or not, we can apply more like we can apply phase up, right? We have a chance of applying phase up there, right? So this is what the condition we need to check here. If at all our j minus I is greater than 1, then only we can apply phase down here. Okay, so I will check this condition and I'll apply phase whether this condition satisfies, then I can easily no undoubtedly we can apply phase down here. Like what is the phase down here? We can increase our power by tokens of j, so phase down will be applied on jth index, right? So as I discussed above, as I discussed before, the ith index we need to apply phase up, and at the jth index we need to apply phase down, right? So we need to what is phase down? We will be increasing our power by tokens of j, and what we will be decreasing our score, right? And we will be moving our j to further move, right? Like previous index, like next index, right? J minus minus, that is. Okay, so if this both conditions fails, like we cannot apply like we cannot apply phase up here or we cannot apply phase down here, right? Then we can simply say that we are at the termination, right? We cannot apply any operation here, so that we cannot go further, right? For going further we need to apply either one of the operation, right? So when we can't apply both operations, then what we can see, that is the end of the operation, right? That is the end of the play. So we cannot further play the tokens here. So at that case we need to return whatever our score is, right? So I'll just return whatever our score is, right? And after playing all the tokens, I'll be returning my score here. Okay, after playing all the tokens, I'll be returning my score here. So this is the code for this solution here, and the best catch of this problem is, so it will first directly makes us to move to a DP approach here, but if when we try to visualize this thing, we can apply a greedy approach only here, and by using 2 pointers we will be easily solving this problem. And coming to the time complexity of this problem is, time complexity is, so as we are only traversing over the array, that will be tokens array, right? So as we are only traversing over the array, and that will be big of n only, right? Big of n, right? And what will be the space complexity here? And as we are not using any kind of space here, and so the time complexity will be n log n, right? As we are sorting the tokens, right? So for sorting the tokens we'll be using n log n, right? Our overall time complexity will be n log n. For sorting, as we are using sorting technique here, we will be using n log n time complexity here. Our time complexity will be n log n. And coming to our space complexity, we are not using any space here, so initially our space complexity will be big of 1 only. Okay, and this is the problem here, and let us quickly run this problem and check whether our code is working or not. So we can see that our test cases are passing, and let us try to submit it. Okay, this has passed the solution, and so this is the approach for this problem here, and so this is the approach for this problem, and thank you for watching this video, and please subscribe to the channel LeetCode.